Right. Okay, people then will write the heading as vectors, right? Write the heading as vectors. Right. Right, people, the first thing you have to understand here is, people, this lesson is another easy lesson coming under applied maths. Okay. Yeah. So now let's see, people, what is really meant by the word vector. Okay. Yeah. Now, you know, people, we know, we have heard about the displacement. Displacement. And next one is the distance. Okay. These two are, people, two physical quantities. Now, you know, the displacement is really when we people have, suppose, 2 points like this, A and B, we can join this AB 2 points by a straight line segment like this. And we can join this A and B by another this way curved path. Understand? Right. Now, suppose somebody is actually walking along this line from A to B. This way. Then you can see throughout his journey, you can very clearly see he has a definite direction. The direction is from A to B. Okay. Now, another one this way walks along the, suppose this is first track, this is the second track. Second guy, when he is walking along this path, people, you can very clearly see his direction of motion is not definite. His direction of motion, the direction is always changing. Therefore, we say he has no definite direction. We say he has no definite direction. But the one he is moving along this AB straight line, he is having a definite direction. Then, people, the length A to B and this length A to B along this track. Okay. The length from A to B, it has definite direction. The direction is the direction of AB line, A to B. Then this AB length is called as the displacement. You know this already. Therefore, the AB is called as the displacement. It is called as displacement because that length from A to B has definite direction. And this curved path, this length is called as the distance. Why? People, this distance, in this case, you can see the length is the distance. But in this case, people, the man he walks along this track has no definite direction. Okay. Then this displacement is called as a vector. Right? This is called as a scalar. Vector mean, people, therefore, it's a vector. Vector mean, people, it has a definite direction. And scalar has no definite direction, and simply we define it has no direction. So therefore, basically, people, our physical quantities in our day-to-day life we divide basically into two parts. One is this way, vectors. Other one is scalars. Examples for vectors, people, you can very easily imagine the physical quantities which have the both qualities size and direction. Size means, another word for this size, we use magnitude. Magnitude and direction, both qualities available, right, for the vectors. Scalars, people, only the magnitude. Magnitude mean people size, right? We can take many examples. People see the examples for vectors. First one here, displacement. Displacement. And number two, people, velocity. Velocity. How to define the velocity? Yes, rate of change of the displacement. In other words, people, during 1 second along this path, along the straight path, during 1 second, the number of meters walked. During 1 second, number of meters walked along AB path is called as the velocity. That means in 1 second, number of meters, the displacement. In 1 second, the displacement traveled is called as the velocity. People, what is the speed? Speed means in 1 second, the distance moved. That is called as the speed. Since distance is not a vector, the speed is also not a vector. Is not a vector, right? So therefore, here the speed is not a vector, it's a scalar. It has only size. And people, third one, under these vectors, we can take force. Force. People, force means what? When we push something or when we pull something, people. For example, suppose we push an old car, right? We push an old car like this, people. We push here. When we push this way, the car, people, you know, the push has particular size. All right. So that means that depends on the strength of the person who pushed this. And meantime, we apply that force, that is called as a force. That force has a definite direction. Therefore, that force has both the qualities, size and direction. Therefore, it is a vector. And when I consider mass, mass, people, has only the size, not a direction. Mass means what? Mass means what? Number of what? Particles a body contains, right? So it has only size, not a direction. So therefore, mass is a scalar, right? What about the weight, people? We know weight. What is weight? Weight, people, a vector. You know, weight means what? Weight means people, it's a force really. Now you will learn under physics, under gravitational field, people, weight is defined to be, now when we consider this way the earth, right? And when we place particular object in the space, right? This object is attracted towards the center of the earth by a force. This object is attracted towards the center of the earth by a force. That force only, people, we define as the weight. Therefore, weight is really a force. So therefore, weight also come in under the category of the vectors, right? Weight. Okay. And like that, people, for scalars, speed, mass, when we consider any real number, people, that's also a scalar. It has only a size. Like that, there are many physical quantities we can put under these vectors and scalars. So therefore, first thing we have to understand here, people, a vector we define as a physical quantity, right? All these are called as physical quantities. any physical quantity which has both the magnitude and direction is called as a vector. Understand, people? Is called as a vector, right? Okay. Now, next thing is, right, throughout this lesson, people, now when we discuss about these vectors, there's a standard way of representing a vector geometrically, right? So we'll understand that first. Now, suppose this direction, that means this is the east, no, this is west, right? Along this east direction, suppose we apply, suppose on an old car, right? A man pushes this, right? Car, people, right? This way, applying 10 Newton force. The direction is east, right? A man pushes this way the car. Applying 10 Newton force. Then you can see that 10 Newton gives us the size or the magnitude. And meantime, the direction is available, east direction. Then this physical quantity is a force, therefore it's a vector. Now, when you represent this 10 Newton force acting due east direction, geometrically, we represent this way. First of all, people, we draw a line segment in the direction west-east direction, right? And we select one scale, 1 centimeter denote 1 Newton force. This way we select one scale, right? 1 centimeter long line segment shows 1 Newton force. That scale is that. Okay, this is a scale. Subject to the scale this 10 Newton force, if we try to represent, definitely, people, we should have 10 centimeter long line segment. Then from this line segment, we take a line segment of length 10 centimeters, like this. Okay, now I take that this way. Right. Remember, this line segment we have drawn in the direction west-east direction because this force is acting on the car in the direction of east. Now, length is 10 centimeters. Right. Now, the force is acting due east, no? Then we put an arrow on this line segment like this. Then see here, the size of this force equal to length of this line segment. And its direction is shown by this arrowhead. So this is the people, the geometric representation of a vector. So therefore, whenever we represent a vector geometrically, people, its size, we of course denote by the length of a line segment. And this line segment has been drawn parallel to the considering vector. And in order to show the actual direction of that vector on that selected line segment, we put the arrowhead pointing to that direction. So therefore, the geometrical representation of a vector is, people, with the line segment and arrowhead putting on that. The line segment is drawn parallel to the direction of the vector, and its length is equal to the size of the vector, and the direction of the vector is correctly shown by putting an arrowhead on that. People, now in this case I told you this scale 1 centimeter is representing 1 Newton force. It is not compulsory to use the centimeters. We can use millimeters or meters as the units of our length. Therefore, people, in this case, we don't care about this unit. So then we simply take 1 unit of length. 1 unit of length. That unit can be measured in any unit. We don't mind that, and we don't care about that. Okay, we simply say 1 unit of length gives 1 unit of the vector. So therefore, people, hereinafter, we don't care about this scale. Understand? Yeah. Then this length of the line segment is equal to magnitude of the vector. And that line segment has been drawn parallel to the direction of the vector. And to show its exact direction now, we put an arrowhead on that. Okay. Now after that, people, this starting point and this ending point, we mark, people, using capital letters, right? So therefore, if I take this point as B and this point as A, then this is called as, people, AB vector, AB vector, and it is written like this, AB, and we put arrow like this. Then see here, vector is starting from A, here, starting from A to B only, this arrowhead points. That is also available here, A to B arrowhead points. So therefore, if you don't have here, and if you only have these, people, then you must understand this vector is starting from A and ending at B. Understand? So therefore, this way, the geometrical representation, again we write like this, AB vector. The meaning of this is AB vector, AB vector. Understand? AB vector. Right. So now, people, this is how we represent a vector geometrically. Understood? Right. Now, according to this geometrical representation, any vector we have, we can, of course, represent by a line segment along with an arrowhead. Then that line segment is drawn parallel to the direction of the considering vector. And its length is equal to what, people? The size of the vector. And to show its exact direction, we put an arrowhead on that line segment. People, hereinafter, in this lesson, whenever you hear the word vector, don't go to think whether it is a displacement, force, velocity, weight, anything. Don't think. We have to imagine suddenly, if it is a vector, it is a line segment with the arrowhead. If you actually think in that way, people, I think you can very easily understand all the theories in this lesson. Understood? Hereinafter, when you hear the word vector, don't think, people, what is that? Is it a force, velocity, acceleration, weight, whichever it is, people, don't consider them. Just imagine, if it is a vector, that is a line segment along with arrowhead. That line segment has been drawn parallel to the direction of the vector. That's all you have to imagine. If you do so, people, I think almost all theories very easily you can absorb without any difficulty. Understood? Right? Yeah. Now, people, the next thing is this AB vector, right? We, of course, use this to represent what? The 10 Newton force acting due east. So therefore, this AB vector representing what? 10 Newton force acting due east. Due east. Okay. Right now, people. Fine. Now, next one. People, this size of the vector AB, size of the vector AB. This is a vector AB, right? Its size is called as its modulus. Understand? Modulus. Right? Modulus. Size of vector AB. Size means people magnitude. Another word, magnitude of AB. Size of the vector AB is called as people, right? Modulus of vector AB. Modulus of vector AB. Modulus of the vector AB, we write like this, people. AB vector modulus. This is a notation. This vertical two line segments together form another sign. It is called as the modulus sign. So therefore, size of vector AB is the modulus of vector AB, and it is denoted by this notation, people. So you know, size of the vector AB is really given by the AB length, no? So therefore, this is nothing but AB length. So therefore, another word here now you learn, modulus of vector AB or modulus of a vector. Modulus of a vector means, people, size of that vector, magnitude of that vector. Understand? So therefore, modulus of vector AB we denote using the symbol like this. Its mean is, people, size of the vector AB, or since the size of the vector AB is given by AB length, it is nothing but AB length. Understand? Right. That's another thing you must understand. Okay. Now, people, when we represent a vector like this, a line segment along with an arrowhead, okay, whatever that vector, people, we don't mind that vector. We represent that vector geometrically by a line segment along with an arrowhead. Yeah. So therefore, people, you can very clearly understand the two qualities available in this vector is, first one is magnitude, size, and the direction, no? Right. Direction. Okay. Now suppose, right, you can see this pen, people, this pen, you can see this pen has a particular definite length. And suppose, people, right, this point of this pen is the direction of the arrowhead, right? So therefore, when I bring this pen to this board, it has a definite length like this, and when I keep this way, people, this point, it points to a particular direction. I am going to take the direction as the direction of the arrowhead like this. Okay, right. Now I close this. Now, keeping this pen at this position, I bring this pen towards me without changing its direction. Now, the pen lies at a new position. Now, imagine the first position. Now, consider the second position. From the first position to the second position, I brought this pen, people. You can obviously see I didn't change its length. And I told you, from the first position to the second position, I brought this pen, people, parallel to the first position always. Then, people, at the new position, when we compare the two qualities of the previous position and now, the length being the same pen, no? I moved parallel to the first position. Then the direction also the same, and arrowhead also the same. Then, people, suppose when this pin, when it was at the first position, represented the vector, then, people, of that vector, the both qualities, magnitude and direction, still available here with this vector, with this position. Then people, we can see, since the two qualities a vector belongs available here also, this position for this pin as before. Then people, since the qualities are the same people, the first position vector represented by the pin and this position, the pin representing what people, the same vector. So therefore people, by this we can get another simple idea, the conditions required for two vectors to be equal. For two vectors to be equal, vector has two qualities, magnitude and direction. If two vectors have the same qualities, the same way, people, that two vectors are called as equal vectors. Right now, people. Now, when we consider a vector, people, vector has two qualities. If two vectors have the magnitude and direction as the same, then the two vectors are equal. People, if something has more qualities, right? For example, can you find two equal children or two equal persons or two equal men or two equal women? Can we easily find? No, people. What's the reason? People, when we consider a person, how many qualities are available with him? Yeah, height, weight, and beautiness, size of the head, hair style, and more qualities available. Therefore, people, yeah, infinity. There are infinity qualities. So therefore, if we need to find two equal persons, people, with these two persons, all those said qualities must be equal. Right? Asking question, twins, people, when you measure, take the twins, people, just measure the length of this nose from one and the other may be different. Weight, people, even a milligram may be different. Everything must be equal for them to be equal, people. So therefore, what I'm trying to tell you is, people, if a particular physical quantity has more qualities, then people, it is a bit difficult to find out another equal physical quantity to that. Why? Many qualities should be equal between them. Then only we can say they are equal. But in this case, when we consider, people, vectors has only two qualities, magnitude and direction. Therefore, if there are two vectors which have same size and same direction, people, then that two vectors are called as equal vectors. Understand? So therefore, consider that way two equal vectors. Okay, that way two equal vectors. You know, any vector we can represent geometrically, no? By an arrowhead along with, by a line segment along with arrowhead. People, if we consider two such equal vectors, and after representing them geometrically, when we consider the properties of that two line segment which represent the equal vectors, since the sizes of the vectors are equal, the lengths of the line segments must be equal. Suppose the first vector is represented by the AB line, second one is CD. So therefore, the first property is, people, what? AB length is equal to CD length, because for equal vectors, they have equal sizes. Number one. People, second one, number two. This line and this line, people, should be parallel, no? Should be parallel. Not only that, on these parallel lines, even, people, the directions may be opposite. The second one is AB parallel to CD. And another quality is there, people. Even though these two are parallel, if I put the arrowhead on this way and other one this way, people, the directions are not the same. So therefore, the third quality is, people, the directed directions should be the same. What is meant by directed direction? A to B direction should be same as C to D direction. So therefore, people, when we have two equal vectors, and after representing that two equal vectors geometrically, we get two line segments. That two line segments, people, have these three qualities. What are the qualities? The lengths are equal, line segments are parallel, and the directed directions. They are the directed directions means, people, the direction the arrowhead points to, they must be the same. So therefore, people, when two vectors are equal, their geometrical representation have these three properties. Understood? Conversely, people, while two line segments represent two vectors having these qualities with them, they together say that consider two vectors are two equal vectors. Understood? Right? So therefore, in this way, right, if you always think about a vector, it is a line segment along with arrowhead, people, all the theories you can very easily observe. So therefore, we have to come to what now? Mathematical language. A vector now we bring to our maths how a line segment with an arrowhead. With that concept, people, I think this lesson is very, very easy lesson. Understand? So that is very important thing throughout this lesson, to understand all the theories. What, people? Any vector, there are infinitely many vectors in our day-to-day life now, people. Any vector, when we speak in maths, bring that vector into your book, how, people, a line segment along with arrow. That's all, people. Don't think anything other than that. If you think like that, people, may be confusing. So there is a time to think after learning a particular extent of this lesson. Then, people, you are okay, right? Otherwise, people, always we try to match this mathematical concepts with our day-to-day life. That's how, people, we usually have that rhythm in our body. Why? We don't like them to go away from us. So we always try to bring to us. Why? To easy familiar. Because some cases are there, but at the beginning, when you bring this concept to your mind, if you try to bring them to you, people, then you try to match, then that is the reason why it gets confused. So therefore, at the beginning, think like this and move along the lesson a little distance. Then, people, you will realize no need to bring them to us. Let they be there. We know your behavior. Then whatever the way you behave, you bring, we bring you into our book in this way. Then you can understand all the theories very easily. Understand, people? Right? Yeah. So then, up to here now, I think you could understand. Okay? Right. Now, people, in this way, there are some different types of vectors we have to discuss. Right. Now, first type is negative vector of a vector. Now, people, when you hear the word vector, you have to familiar that what? Line segment and arrow. Don't think anything other than that. Okay? Right. Now, when we consider negative vector of a vector. Negative vector we define like this. Now, suppose vector means arrowhead, no? Line segment with arrowhead, no? This is a vector. Suppose the vector is AB, right? This vector is now AB vector. This is how we write this, AB vector. Now, people, the same line segment I draw here parallel to this, and we put AB, the same points as the same. And only thing is the direction, this arrowhead, we take in the opposite direction. Then you can very clearly see this line segment and this line segment are equal in length. They are parallel. And only thing is the direction opposite. Understand? So therefore, this vector, how to write that vector, people? The arrowhead is pointing from B to A. Therefore, this vector is written as BA vector. BA vector. Understand? Huh? Because this vector is starting from B, ending at A. So therefore, this is written as BA vector like this. Then when we consider this AB vector and people, BA vector, you can very easily see the direction only, opposite. Other two qualities, the length and the parallel nature of the two line segments are still the same, but the direction opposite. So therefore, people, this BA vector is called as the negative vector of AB. So therefore, when I write an equation involving these two vectors, we can write, people, this way: AB vector and second is BA vector. This BA vector is the negative of AB vector. Understand? BA vector is called as the negative vector of the AB vector. So therefore, the same thing we can write like this, no, people? This equals this means this equals this, no, right? So therefore, BA vector is equal to minus AB. Right? So directions are opposite. People, the opposite nature, we explain in maths, put in minus sign. Remember, if something is opposite to another given thing, then we use to one minus. So then the idea of opposite is, of course, in maths we use with negative sign. Understood? Right? So therefore, this is how we can relate the two vectors. Then here you have to understand one more thing. People, you can very clearly see here. In the left hand side, order of the letters, first B, then A. Right hand side, the places interchanged. A came first and then B. Then people, remember, in this case, when we interchange the letters of the vector and write new vector, another minus sign, extra minus sign coming before. Right? Here, these two letters interchanged. That's how we got this. Then what happens? Extra minus sign coming before. That means when we write, people, PQ vector in another way, it is minus QP. Minus QP. Understand? So therefore, when we interchange the order of the letters, extra minus sign coming. Remember that too. Right? So now this is the first vector, negative vector of a vector. Right? We know equal vectors. Another vector type we discuss here, people, that vector is called as the unit vector. Unit vector. Unit means, people, size is 1. Size is 1, right? Unit vector means size is 1. Now, suppose, for example, in this west-east direction, we apply 1 Newton force, this direction. Then once we represent this 1 Newton force, it is a vector now. I have to draw a line segment of 1 unit long. This is 1 unit. Okay. And that line segment has been drawn in the direction west-east. Now, to show the exact direction, I have to put an arrow like this. So therefore, people, in this vector, its size is 1. So therefore, this vector is called as a unit vector. Unit vector. Okay, unit vector. Now suppose this way. We have a vector AB. We have a vector AB. Suppose the modulus of the vector AB is 3. You know what is meant by the modulus now. Size of the vector is 3 units. The units also we are not going to consider. If it is a force, the unit of the force is newtons, no, 3 newtons. If it is a velocity, the vector, 3 units means what? 3 meters per second. They are also the unit we are not going to consider, right? In maths, people usually we don't consider about the units, but in physics and chemistry, people units are very important. Put in the units final answer, the final answer, people you get another 5 marks. But in maths, people we don't care about the units. So therefore, most of the time when we speak about these vectors or anything, people, I'm not going to speak about the units because that is not anyway important. So if you lose what your final answer, the units, never mind, people, you get full marks. But that in physics and chemistry, people, you can't do like that. For the units, you get marks. Right. So now here, AB modulus is 3 units. So therefore, I'm going to divide this AB line segment into 3 equal parts. So therefore, each part is what, people? 1 unit, no? 1 unit. Right, this is 1 unit. Okay, now AB vector, the arrowhead should be pointing from A to B, no? So then I put here, arrowhead here, arrowhead here, arrowhead here. Then this each vector, now unit vector. This also unit vector because the size is 1, no? This also unit vector, right? If I take this unit vector as U and putting a small line segment in it under that. People, this notation, remember, simple A, we underline this. This notation, people, we use as another notation to represent a vector. The idea of the vector is really given by this line segment, underlined line segment, this one, right, people? So this one only representing A is a vector. That notation we use for our convenience of writing. Now, people, suppose AB vector, we write like this. In our workings, we have write in every step this AB vector like this. People, it is a bit boring, no? Then what we do? We take like this. Let AB vector is simple A vector like this. We take a small notation like this. Then at every places of AB vector, we need to write, people. Instead of that AB vector, we write what? Simple A vector like that. So therefore, that is another way of representing a vector for our convenience of day-to-day mathematical works. Okay. Now suppose like that, this vector from here to here, length is 1, direction is available. So therefore, this is a unit vector. So therefore, I can take this as U. Then people, what is from here to here? This segment also having the same qualities of this line segment. Length being equal on the same line, therefore the 2 line segments are parallel, and the arrowhead also point to the same direction. So therefore, if we take this as unit vector U, this should also be the same unit vector U. Similarly, people, this one should be U. Then what is this U? The unit vector along the direction of vector AB. Understand? Along the direction of the vector AB, the unit vector is U. People, can you see? By adding this U, and this U, they together 3U, no? This U, this U, this U. 3U. This 3U together form the whole line segment AB. Correct, no? So therefore, this 3U vector should be equal to AB vector. Well, obvious thing. U, 3U. We place first U, after that second U, after that third u, then the whole line segment is AB, no? Therefore, AB vector is equal to 3u. But what is this 3 people? Here, modulus of AB vector. Then I can write it like this. 3 is the modulus of AB vector times u. So therefore, people, this is another important thing that we have to understand. What is that, people? AB vector we can write as how? AB vector modulus multiplied by what? A unit vector along the direction of the vector AB. Understand, people? So therefore, remember, any vector we can write as a product of its modulus multiplied by the unit vector along that direction. And can somebody answer, when we are given a particular direction, suppose the direction west to east, right? West to east direction is this. Right? West east direction is this. Along this direction, can someone tell me how many unit vectors available? How many unit vectors available? How many unit vectors available? Unit vector means the size of the vector is 1 unit. How many such unit vectors available? That means, people, right? One answer coming as infinity. Good. Right. Actually, the thing is this. Unit vector mean, people, that should be of length 1 unit, no? That unit can be 1 centimeter or 1 meter or 1 millimeter or whatever it is. We don't mind about the unit. Right, people? Now, I am drawing this way lines. Okay. Now, in order to find unit vectors available, I have to reserve line segment of unit 1, length 1 unit, this way. Then we can say this is 1, right? This is another one. This is another one. In everything, the direction is rightward. So then, taking like that only, most of the students said there are infinitely many unit vectors. People, that's true. That's true. There are infinitely many unit vectors along that direction, west east. But people, when you take any 2 unit vectors, take this one and take this one. When you take these 2 line segments, people, what can you say? The lengths are equal, 1 unit. The line segments are parallel because they lie on the same line, no? And the directed direction also, people, what? Equal. Then what can you say? The unit vector here we considered and the unit vector here we considered being, people, equal. Then your answers are correct. The answer was what? Infinitely many unit vectors available along a given direction. That's true. But people, what can you say secondly? Even though there are infinitely many unit vectors along a given direction, people, all those unit vectors are equal. If all are equal, people, how many unit vectors then exist in? Only 1. Why? The rest ones are equal to that. Understood? So therefore, hereinafter, don't say along a given direction. Along a given direction, people, there exists in only 1 unit vector. Only 1 unit vector. There are infinitely many, people, but they are equal to that single one. Understand? Okay. So therefore, to a given direction, there exists in only 1 unit vector. Right? So now I draw another line which is parallel to this one. Here it is this. I again reserve what? Line segment of 1 unit length. Then I take this one and this one, put in the arrowhead like this. Now take this and this. What can you say? The length of this is equal to this. This line segment and this being parallel. And the arrowheads point to same direction. So therefore, this vector and this vector again equal. That is why people, wherever now, I take this line out from the board, but parallel to itself. Again, I take 1 unit length line segments, and I compare that and here. That three qualities which required for two vectors to be equal available here too. So therefore, people, along a given direction, there are infinitely many unit vectors, but people, they are equal to each other, right? So therefore, finally, there is only one, right? To that one only, people, all the rest are equal. So therefore, along a given direction, there exists in one and only one unit vector. Understand, right? Then here, AB vector, you can write its modulus multiplied by unit vector along that AB direction. Or else, people, if you need to find a unit vector, the unit vector, we don't use the unit vector. If we need to find the unit vector along a given direction, we can use this equation to find that. But people, if you subject this u, taking this to left hand side denominator, I can write AB vector divided by its modulus as u. So therefore, unit vector, the unit vector in the direction of the vector AB, we can obtain dividing AB vector by its modulus. Understand? So therefore, u, the unit vector in the direction of the vector AB, you can write like this. Understood, people? This is also another one important result. We will use this in the calculations. Understood? Right. So that is the meaning of unit vector. People, another type of vector, right, we define, it is called as the null vector or zero vector. Null vector or zero vector. Null vector or zero vector. Next type is null vector or zero vector. It is denoted by people 0, we underline like this. Yeah, this null vector or zero vector mean people the size of the vector or the modulus of the vector or the magnitude of the vector is 0. Size is 0. Such vector is called as the zero vector. Can somebody give me an example to understand this? Size 0 and it's a vector. Yeah. People, we can take one example like this. Now suppose here, this point is A. Along this line, a person is walking towards this A. The current position of the person I take as B. Right. Now we measure the displacement to this person from A. Since we measure from A, our arrowhead should go from A to B, no? Right. When the man is somewhere here, the displacement of this man from A is given by AB vector. AB vector. Suppose this man is 5 meters away from this point A. Then what is the AB vector? 5 meters, the direction is this. Rightward, because displacement mean people a vector. Since it is a vector, it has a definite direction. The direction is A to B. Now people, little by little, this man is coming towards the point A. Then the displacement to this man is measured from A, no? Then that displacement having the direction rightward. But as the man comes towards this A, the gap between this A and this man decreasing. Even though the gap decreasing, the direction of the displacement is rightward direction from A. One occasion, people, while this man coming this way, one occasion the man comes onto the point A. That occasion, people, the gap is 0. Even that occasion, people, we have been measuring the direction to rightward. The gap is 0, but still the direction is what? Rightward. Why? We have been measuring the direction to rightward. So therefore, in this case, size is 0, direction is rightward. Size is 0, direction is rightward. So that is an example, people, for null vector. Therefore, there are vectors which have the size 0, but having a direction. People, at that moment, the gap 0, the direction is rightward. Why, people? We have been measuring the direction to rightward as the man coming towards A. Once he comes on to A, people, still we are measuring the direction to rightward. So therefore, this null vector has a definite direction. Right? Okay, so that is how we define the null vector. People, remember, mathematically, the direction of null vector, we define it can get any direction. It doesn't mean what? Its direction is not definite. No, it has a definite direction. That definite direction can be any direction. People, can somebody tell me, very simple question, how many directions available around us? Tell me. That's also another very simple question. How many directions available around us? One student saying 8. Another one saying 360. Any other answer? Another one saying infinity. Yeah. Any other answer? Right. People, now, yeah. Imagine a point in the space. Space means this, right? Open area. Imagine a point. If not, imagine your point as the point of this pin. Can you see that point of the pin? Right. From this point, draw line segment, draw lines along any direction you like. This way we can draw, this way, upward, this way, downward. How many line segments, people, we can draw starting from this point in the space? Is it 8? No, people, infinity. Along every line, people, there's a direction. Therefore, remember, in our space, number of directions is infinity. Understand? Number of directions is infinity. Understand? No longer we say 8 or 360, infinity. Understood? So therefore, this null vector can take any direction of that infinitely many directions. Okay? It doesn't mean its direction is indefinite. It has a definite direction, permanent direction, fixed direction. That direction can be any direction. Understand? Right? That's how we simply define the direction of the null vector. Understood? Okay? Yeah. Now, people, by this part so far we learned. Do you have any question? Because we have to lay this foundation strongly. Otherwise, people, this vectors confusing, right? The lesson is confusing, but this is very easy. Applied maths means, people, really applied. That means apply means, people, day-to-day life, we can see these things. Only thing is, those things, of course, we bring to our consideration, converting them to mathematical form. right? That link between the conversion, if you very carefully understand, then people very easily we can match this mathematical but subject with our day-to-day life. Then of course the issues we can minimize. Okay, all right. So now asking a question like this, can you explain a unitary mass once again? What is meant by unitary mass? Unit mass. Yeah, unit mass means, now when we consider 1 kilogram mass, 1 kilogram or 1 gram. Okay. U. What's meant by U? Unit vector, you're asking. Yeah, unit vector means, a unit vector means people, the size is 1. Size is 1. Unit vector means size 1 such vector. That size can be measured in any unit, but it is 1. Okay, so therefore don't think much. What is the size? If it is 1 and if it is a vector, then that is a unit vector. Right. Okay, people, now we have to take down the notes regarding the discussion so far we did. Then we go to the next part. Okay, right. So we discussed almost 1 hour. I think you got a particular idea about this vectors, right? I will take down this one, and thereafter we can go to the next part, right? So this lesson is very interesting lesson, people. After the second lesson only, this is very interest. And then when we work out questions, people, many applications, they are available in this vector. Remember, when we do an engineering degree, people, there are many applications with this vector. When you do electricity, electronics, right, magnetic field, with everything, people, this vector mixing up. Without vector, people, nobody can do maths. Understand? Right? So vectors are very important ones. Right? So this vector, actually, when you consider this vector, people, in most of the applied maths lessons, the vector lesson involving. Right? In most applied maths lessons, questions available involving these vectors. If you, of course, lack of knowledge of these vectors, people, those questions you can't work out. Then, of course, you can't go to the highest place. So therefore, understand this vector lesson. It's a very easy one, very simple concept available, a very simple idea, people. Don't think much, right? What I told you, according to think, that's enough at the moment. Then gradually I know how should you go to the required level. Okay, right. Asking combined maths is pure. See, so for combined maths and pure maths, do we need to take different books? Yeah, people, now combined maths is the common one. In combined maths, one part is the pure maths, other part is the applied maths. For this pure and applied, you have to keep 2 books, right? And the other thing is, people, right, this pure maths lesson, the trigonometry is the pure maths lesson, and this vectors is applied maths lesson. And the other thing is, people, when you finish a lesson, right, keep that book aside and take another new book for the new lesson. Understand? And Very carefully you have to keep that book, because if you lost that one, people, the whole lesson will be lost. Understood? Okay, don't write everything on the same book. Sometimes you might say, no sir, what if we write in the same book, right? Okay, so then we have to study them again, all the things before examination. No, then you have written down everything, mixing up, people. That is not the good way. Why? So then once you need to get the full idea about the particular lesson, so then we have to what, turn the pages everywhere to find out the locations. Don't do that one, people. Take separate book for separate lesson and carefully keep that books, right? Yeah. Okay, so then for pure maths, one book, and applied maths, one book, right? So this lesson, vectors come in under applied maths. The trigonometry one come in under pure maths, right? Yeah. Okay, so then we'll write, people, the heading as vectors. Right? Then we'll write one by one, right? The note. Okay. Write down like this. Write down this way. Any physical quantity which has the two qualities magnitude. Magnitude means size, and direction. Magnitude and direction. Is defined as a vector. Defined as a vector. Right now, people. Right. Write down the physical quantities which have only the magnitude, are called as scalars. Right? Scalars. Right. Examples you can write for vectors and scalars. Vectors, what, people? First one, displacement. Scalars, distance. Number two, weight. Here, mass. Velocity. Force. Acceleration are examples for vectors. Here 3 real number. Right? They are scalars. Right now. Right. We'll come to the next knot. Write down some heading as this way. Geometrical representation, geometrical representation, geometrical representation of a vector, geometrical representation of a vector. Right. Geometrical representation of a vector is the heading. Then we'll write people under that like this. Write down a vector is represented by a line segment. By a line segment along with an arrowhead. Along with an arrowhead put on this line segment. Put on this line segment. The line segment is drawn. The line segment is drawn parallel to the direction of the vector, parallel to the direction of the vector and its length is equal to, and its length is equal to, and its length is equal to the size within bracket write down people magnitude of the vector, close the bracket, of the vector. Write down to the same sentence, same line. The arrowhead is put on this line to the exact direction, of the vector. Start from new line. For instance, consider a force of 10 newtons. Consider a force of 10 newtons acting in the direction due east. Right. 10 newtons, right? 10 Newton force. Direction is this. And then what we do, people? We draw a line segment like this. We draw a line segment. What is the length of this line segment? 10 units. We do not worry about the units, whether it is centimeters or millimeters or meters or decimeters. So we don't worry about that. 10 units. 10 units. An arrowhead we put like this. And we put here A and B. Okay. This is now what, people? A, B vector. How to write that? This way. This one we can write again. A, B vector, how to write? It's written like this. A, B. Yeah, then by this AB vector, what we get? 10 Newton force acting due east. Understood? Right. This says 10 Newton force acting due east. Right? Yeah. Now, write down the size of the vector AB this way, right? We write size of the size of the vector AB. Right, people, write down this one. The size of the vector AB. Size of the vector AB is called as what? Its modulus. The size of the vector AB is called as its modulus. Its modulus, and it is denoted by AB vector modulus. How to read this? Modulus of AB vector. Modulus of AB vector. It is really equal to what? AB length. right? The size of the V vector is called as its modulus n. It is denoted by AB vector modulus. So then the same thing I wrote, AB vector modulus of AB vector. It is people equal to AB length. Understood? AB length. Right now? Yeah. Right. Now people will discuss types of vectors next. Right? Yeah. Write down the next subheading as people. Types of vectors. Types of vectors. First one. Equal vectors. Right. But people, what is meant by these equal vectors? The two vectors are equal. So when two vectors are equal, people, all the properties of these two vectors must be the same. Since a vector has two qualities, the two qualities of these two set vectors must be the same for them to be equal vectors. If the magnitude and direction of two vectors are the same, then people, that two vectors are called as equal vectors. After representing such two equal vectors, people, geometrically, we get two line segments now. That two line segments have now three properties. What are the three properties? The line segments are equal in length. They are parallel. And the directed directions of the line segments. What is meant by the directed direction? The direction to which arrowhead points are also the same, people. Understand? Right. Then we'll write, people. Add on. If the size and direction, if the size and the direction, if the size and the direction of two vectors are the same, then the two vectors are called as equal vectors. Equal vectors. Now write down. After representing these two equal vectors these two equal vectors geometrically the two line segments have the following properties. The two line segments have the following properties. Have the following properties. Write down, people, one by one. First one. Write down, line segments are equal in length. Line segments are parallel. Next one, people. The directed directions. The directed directions of the line segments are the same. Are the same. Are the same. Write down, people, starting from new line. Suppose two equal vectors are represented by AB vector and PQ vector. Suppose two equal vectors are represented by AB vector and PQ vector, right? And then you can see, people, what? AB line segment. This is the PQ line segment. Then we can say what? AB length is equal to PQ length. AB parallel to PQ. A to B direction. Same as P to Q direction. P to Q direction. Right, people, take down this note. Right, people, now for the next month, month of November, another new registration will be done. Now, this today class registration, people, I think I put 3-4 days before. till the tomorrow morning, people, there were nearly 18 students registered. In between 8:55 and 9:10, the rest of the students are registered, and another 3 were in the pending category. Now only I approved them. So it's a people bit inconvenience to both parties. For the next month and month of November, people, new registration will be done. So its link I'll put soon after the class. Today itself, please register, people. Otherwise, the both parties, soon after starting the class, while I am teaching here, I can't do this one. And in your point of view, some of the students phone to my made calls to my phone, but I am not answering during the class. Both parties will find particularly inconvenience. So therefore, people, today itself, register in the classes. For the next month of November, for the whole month, the registration will be done. Okay, so therefore, send you a message here, then I'll approve here. Okay, right. Most of the students, I think, today unable to join the class because of late registration. Right. Okay, then we can take down this. Right. And then, people, this AB vector and PQ vector being equal, right? So we'll write that also here. AB vector is equal to PQ vector. Then we can write this. And why you can take, people, an example. Write down like this. Consider the parallelogram ABCD. Consider the parallelogram ABCD. We take this as the parallelogram. Well, you know geometrical properties of a parallelogram. What are the geometrical properties? The opposite sides are equal and parallel. These two are equal and they are parallel. These two separately equal and parallel. Suppose this is A, B, C, D. This AB is parallel to this and equal. This AD is parallel to BC and equal. Then, people, here we can find two equal sets of vectors. Yeah, people, here. Yeah, there are some more important properties. Opposite angles are equal, diagonal bisect each other, and so many available, people, right? But I'm speaking only about the important properties here. Right, people, now here, can you give me two sets of equal vectors? This length being equal to this quality satisfied. These two are parallel. Second quality satisfied. The direction of the arrowheads being the same. So therefore, people, AD vector and BC vector are equal. Right? Here you can see, people, AD vector is equal to BC vector. The first equal sets of vectors, these two. Secondly, people, AB vector is equal to DC vector. This is how we take that. Okay, right. Draw this parallelogram and take down this. Right. Next type of vector. Write down negative vector of a vector. Negative vector of a vector. Negative vector of a vector. Yeah, we'll write one sentence. Write down like this. The vector we can obtain by reversing its direction. By reversing its direction. Is called as the negative vector. Is called as the negative vector of the given vector. Here AB vector. A to B direction is this way. I copy this AB line segment parallel to itself this way. B, A. They are equal in length. The direction is reversed. Then people, this BA vector, this vector is B to A, people. See here, always this arrow head is pointing to what direction? Starting from an ending point, you can understand, no? Then starting point, we start to write this BA vector, right? This is now BA vector. This is now AB vector. The relation between AB vector and BA vector is, people, this. BA vector is the negative vector of AB vector. Or multiplying both sides by minus sign, you can write other way. What, people? AB vector equals minus BA, right? Or AB vector is equal to minus BA, right? Both are correct, right? Then here you have to understand what, people? When we interchange the order of the letters involving in the vector, here A, B, right hand side, B, A, this order interchange, minus sign coming. Okay. This is how we define, people, negative vector of a vector, right? Now, next one we'll write, people. Next one, write down. Unit vector. Unit vector. Write down like this. The vector with the size 1, is called as a unit vector. A unit vector. Start from new line, people. For a given direction, They are exits. They are exits. They are exits. They are exits. Only one unit vector. Only one unit vector. Only one unit vector. Right? Pattern like this. Consider the vector AB. Don't write the word vector. We'll write like this. Consider the vector AB. Consider the vector AB. If the unit vector in the direction from A to capital B is U. Underline this U. If you underline this only, this becomes a vector. Otherwise, this is not a vector. From A to B is U. Underline this. Then the unit vector, simple U. Underline that. Is given by U equals AB vector divided by AB vector modulus. Right. Or people, the same thing you can write by using the cross multiplication to this end. Right? Or AB vector is equal to AB vector modulus times U. AB vector modulus times U. Understood? Right. Right. And people, as I told you the previous day, if you need to watch the recording, please your email address, right, send to me. Then I am actually adding you to the user category. Then you will receive an email asking to activate your Zoom account. So something to fill there. And send it back. Then people, here I get that one, then I up to you, then I give you the link of the recording to your WhatsApp group. Okay, again you have to fill something there, then I can up to you. Thereafter only you can watch the recording. Okay, without of course activating your Zoom account, people, though you click that link available in the recording, you can't watch. Right. So last week also some student, they got the link like that and watch the recording. Right. Okay. Next one, write down, people. Next type of vector is null vector. Null vector. Null vector, or sometimes called as zero vector. Right? The notation is this. 0, you have to underline now. Right. Right. I don't like this. If the size of a vector is 0, if the size of a vector is 0, then this vector is called as a null vector or zero vector. A null vector or zero vector. Null vector or zero vector. Right. Now, people, next on. That's all the different types of vectors at the moment we are supposed to discuss. Right. Now, people think this situation also very important. Right. Now, suppose this way, a line segment, say AB, suppose this AB length, okay, AB length is 10 centimeters, right? 10 centimeters means 10 units, right? Now, size of the vector is 10 now, right? Next one, suppose another parallel line segment to this AB, we have PQ like this. Suppose this PQ is 5 centimeters or 5 units, right? People, these two line segments are parallel. Suppose PQ, AB are parallel. AB parallel to PQ. And the directed directions are also the same. Right. Then people, between this AB and PQ, we can establish two equal vectors like this. You know, the conditions required for two vectors to be equal are what, people? The corresponding line segments should be equal in length. The line segments should be parallel. And the directed direction should be the same. Out of that three requirements, people, already two requirements are fulfilled by these two line segments AB and PQ. What are the two requirements already fulfilled? AB and PQ are parallel, given here. And the directed direction, the same, well obvious by the diagram. Then in order to generate or establish two equal vectors, we have to match the length of the two line segments. People, now you can see AB length is equal to 2 times PQ length. Why? PQ length is 5. 5 into 2 is 10. 10 is this. We get. Understood. Now, when we consider this, right? Now, the left-hand side length and right-hand side length being equal, you accept that. Other two qualities, the parallel nature and the same directed direction nature, already available in the diagram. Then this and the properties available in the diagram all together, when we consider the three requirements for two equal vectors are satisfied. Then people, if I write this kind of statement, AB is equal to 2 times PQ, this way if I write, do you agree with me? Yes, the people who agree with me, put the message. Yeah, people. If I write this two data along with this, right? I can try it like this. Yeah, people, because all the three qualities now available in this, understand? So people, the result by this part I expect to take is this way, people. Here you can see this 2 we had to put here in order to match or equate the left length and the right length. Suppose people, we don't know this exact length of AB and exact length of PQ, we don't know, but we know these two line segments AB and PQ are parallel and the directed direction also being the same. Only thing is, to match the lengths, we don't know the actual lengths of AB and PQ. That means we don't know what number here we have to put. Here we put this 2 because of we had this exact length. Now suppose exact length of AB and PQ we don't know. Then people, even though we don't know, instead of this 2, there should be a particular number coming when we match what that AB length and PQ length. Though we don't know that on people, there exists such, definitely there should exist such value. That value, then we can write as people K, AB is equal to K times PQ. What is K, people? K is a real number. This kind of real number K available. At the moment, we can't calculate because we don't know AB length and PQ length. So therefore, people, whenever you see two parallel lines, right? Now suppose we have this way. Only thing we are given, people, AB and CD, we are given AB, CD are parallel. The directed direction also not given. Sometimes the directed direction may be the same, or sometimes they may be opposite. Even though people, we can write, if we are given that two line segments, these two line segments are parallel, then we can write AB vector is equal to K times CD vector. Then you might be asking, so what if the directions, the directed directions are opposite of this AB and CD? Then people, this K will take what? Negative real number. If the directed directions of AB and CD being people the same, this K will be positive real number. Understood, people? So therefore, this idea also very important when we work out questions. We'll take down that as a note. Any question here, people? I think you could understand this. Understood? Right. I done under note. Under a note. Note number 1. Right. I don't like this. Suppose the two vectors, AB vector, write down. Suppose the two vectors, write down in terms of vectors. Suppose the two vectors AB vector and PQ vector parallel to each other. Parallel to each other. Draw this diagram, people. Draw this diagram. Draw this diagram. Then you can write simply. What's people? Then we may write simply AB vector is equal to K times PQ vector. Right, people, what about this K? K is a positive real number when the directed directions of AB and PQ are the same. In this case, people, these two arrows, they indicate the two vectors are parallel. Understand, right? If we actually ignore these arrows, people, because we are given that line segments are parallel, that's much better, but I think you have put that then, right? So then we'll put them, we'll write then AB equals KPQ, where K is a positive real number when the directed directions of the vectors are the same. When where K is a positive real number when the directed directions of the vectors are the same. Part B, people. AB is equal to K times PQ where K is a negative real number. When the directed directions of the vectors are opposite. Understand? Right. Right. Now, people, note number 2. We'll come to note number 2. Suppose here like this, we have a AB vector. Right? We have a AB vector. On the line AB, we have a point C. Right? That point C divides this AB line segment internally in the ratio 1:k. 1:k. AC divided by CB, 1/k. Now my question is to establish a relation between AC vector and AB vector. Okay. Write down like this, note number 2. Write down note number 2. Write down, consider the line segment. Consider the line segment capital AB, not a vector, line segment capital AB. Suppose point capital C divides the line capital AB, internally in the ratio AC divided by CB. AC divided by CB equals 1/k. 1/k. People, the same ratio we can write this way too. AC E is to CB equal 1 is to K. This way also we can write it. AC is to CB equals 1 is to K. The same thing this one, huh? Right. Right now, people, can you tell me the AC length in terms of AB length? The AC length in terms of AB length. Grade 5 question I am asking. Suppose this way we have a line segment AB. Its length is 10 centimeters, for example, right? 10 centimeters. There's a point, all right? C on this line maybe. That C divides this line AB internally in the ratio 1 is to 4. AC is to CB equals 1 is to 4. Then my question is, what is this AC length? That is my question. Yeah, can somebody give me this answer? Yeah, people? How to take this AC length? Yeah, first of all, yeah, to come in. How do you get this one, people? It is this. First, this whole length AB 10 centimeters, we divide by the sum of the ratios 1 plus 4. And we need this length AC, no? That AC length is corresponding to ratio value 1. Then this one we have to multiply by 1. Then what do you get? 10 divided by 5 is 2. 2 into 1 is 2. That's how we take. Like that, people, how do you write this AC length in terms of AB? Yeah. AB whole length, we divide by people sum of the ratios 1 plus K. And since we need this AC, the corresponding ratio value 1, we multiply this by 1. This is our AC. Okay. Then this one we can write AC length is equal to this 1 upon K at the denominator. I can write 1 divided by 1 plus K and AB. This way I can write. Now, people, can you establish two equal vectors by using this relation? Yeah, possible. This says what, people? AC left hand side length and the right hand side length being equal. True. And you know, AC and AB lie on the same line, no, people? Then they are already parallel. Lengths are equal on both sides. The line segments are parallel. Third one, when we go from A to C and secondly A to B, the directed direction also equal. Then two properties available in the diagram, third one available here. Then all these three we can include into one statement if I put this way arrows on the left and right. Am I correct? Now, by this vector equality, do we have that two properties available on the diagram? Yeah, AC and AB are parallel. Very obvious because same line, no? AC and AB are parallel. Other one, A to C directed direction and A to B directed direction. When we move from A to C, the arrow point in this way, A to C, A to B, the same direction. People, then we can generate here two equal vectors in this way. Right? We'll write down that one now. Write down this in people. Write down like this. AC length is equal to AB length divided by 1 plus K times 1. That means what, people? AC length is equal to 1 over 1 plus K AB. Also, by the diagram, AC parallel to AB and A to C directed direction is equal to A to B directed direction. Then we may write. What, people? All these three qualities we can now put in one. How? Put in vector notation here. Right. AC vector is equal to 1/1 plus k AB vector. This way we can generate. Understand, people? Right? Yeah. We'll come to another very simple example, right? Right. Write down an example. Right, people, now we have like this. Here a vector AB. Point C is here, dividing by 2:3, right? Now suppose like this, let AB vector is simple A. Right. As I told you, for our convenience of writing, people, some occasions simple letters we use instead of this long way. Now AB vector is simple A. My question is this, people. Write this AC vector in terms of A. Write AC vector in terms of simple A vector. That's how we write. That's what we need to write, people. Yeah. Then how to write, people? AC, AB are on the same line segments. They are parallel. Directed direction also the same when you move away from A towards B and C. Now only thing is we have to match the equality of AC and AB. Then how to write, people? AC length is equal to add the ratios. Right, 2, 3, when you add 2 plus 3 come in. Divide AB length by the sum of the ratios. And to take this AC, multiply by the relevant corresponding ratio figure, 2. Understood? Yeah. Then we get what, people? AC is equal to 2 divided by 5 AB. Now we can write. Diagram gives 2 properties. This gives the next one needed. Then we can write, therefore, AC vector is equal to 2/5 AB vector. But for this AB vector only, people, they use simple A vector, right? So then this gives us, hence, we can write AC vector is equal to 2 divided by 5. AB vector only, we use simple A vector. Understood, people? Right. Okay. Now any question here today, people, under the lesson? Right. Today we are supposed to come to the end of the lesson. Right. Next day, people, we go from here. Next day only, people, we come to calculation part. Any doubtful place today in the lesson? No need to be hurry, people, to learn. Carefully learn this one, right? So we have enough time. We have enough capacity. We can do well everything. No need to be hurry. the people, they are going faster, let them to move like that. They also will be writing the paper with us, no? Okay, right? So therefore, we don't have such hurry nature in our course to follow this. We learn everything well, clearly, right? A crystal clear, and then we go to having a good idea. We'll discuss the questions. I think so far the trigonometry, I think even though not 100%, some of the majority of you could manage questions. But remember, people, we haven't finished that trigonometry lesson. We take again those questions. Once we do those questions, I am sure that you'll be able to do all the paper questions, and 23 questions you can very easily manage. Okay, like that, people, I try to bring you in this lesson to that level. So therefore, patiently we'll discuss this. Any questions, people, today? No questions. All right, people, then today I come to the end of the lesson. Another for the month of November, people, we again register new link, and you will receive to your email or your WhatsApp group, people, especially WhatsApp group, you get a new link. People, you have to register that as soon as possible to avoid the late registration gives people as more inconvenience to both parties. Therefore, today itself, register in the class. I think we don't have any question. So then, people, we meet next Monday, right? So then, nice week to everybody. We meet next Monday in the morning, 9 o'clock. Bye to everybody.